so when I reviewed way batteries are today, I realized, boy, consumers are kind of caught between two extremes. On the one side, we have the traditional lead acid battery. It's been around for a long time, it's safe, it's reliable, it's cost effective, but it doesn't quite meet the needs of our new applications. On the other side, consumers have lithium ion and nickel metal hydride battery technologies, but these are new, they're not proven safety factors, and they're very, very expensive. I said, I think I can solve this problem, and I went back and I looked at how batteries had been made and what we had learned. And I found this technology called bipolar battery designs from 1924. And it really did make batteries better. It made them lighter weight, more powerful, and higher energy density. But there were some problems. I thought, well, what is it that we really need to solve here to make a bipolar battery reliable, hit warranty, and still meet the cost points that people need today?
After I retired from Delphi and started doing some consulting on my own, a mutual friend of Ed Schaefer's and mine introduced me to Ed, and he said, I think he's cracked the nut. Now, in the battery world, bipolar is sort of the holy grail. Everyone knows that if you can do it, you've got a much more efficient product.
So what is it about a bipolar battery design that really does make it a better battery? And it's simplification. Bipolar refers to that a single electrode has both a positive and a negative electrode on it in one part.
It's the way it usually works. Someone from outside the box comes in and figures out the problem.
It's the high surface area that reduces the resistance and gives us more power. It's the efficient use of those electrons that then gives us more energy and allows us to use less active material. And we just simply stack these things up to get 2, 4, 6, 8, 10, 12 volt battery.
Actually, we can put the same amount of energy in the vehicle with less weight. So that's the key. Higher voltage, less weight.
The world is starved for better batteries, be that the holy grail market for utility grid storage or automotive electrification applications. Today's batteries just don't serve those needs very effectively. The Green Seal battery solution has the opportunity to disrupt those markets completely, for the first time offering a cost-effective solution that provides the cycle life, the energy and power density, and the recharge times demanded by those applications.
This battery is easier to manufacture than a prismatic battery simply because there are less process steps. There's 23 steps in a conventional prismatic design. We have 10.
The Green Seal battery solution, for the first time, cracks the code and provides the required functionality and price point that these emerging markets need.
This battery can be manufactured in larger scale, first of all, because it uses existing components that already existed in the battery world. Lead oxide manufacturing is already part of any battery manufacturer. We use the same. The pasting operation is the same as a conventional. We can paste our electrodes on the same equipment that pastes conventional battery grids. At that point, now we changed a little bit. Most battery manufacturers then take those pasted grids, stack them up into things called elements, which is alternating positive and negative plates with a separator between, cast a strap on top of it, and then insert that element into a molded plastic box. We take our electrodes and stack them up like a sandwich with an AGM separator separating the active material, and then mold the whole box around the unit. That's why it's like a brick. We've molded a brick.
We can give you the same amount of energy or the same amount of power, but with a whole lot less weight, almost 34% less weight. We're also more efficient at using a material, so as a result, we use less lead. We actually use 46% less lead content in our batteries for the same amount of energy.
The Chinese e-bike market represents an enormous opportunity for the Green Seal solution. That market alone is in excess of $5 billion a year, with about 125 million bikes on the market today and 25 million growing annually. That's just one market that we find very attractive and where we can satisfy a significant need.
So at the end of the day, a GreenSeal bipolar battery is a rechargeable lead acid battery. Now here's the good news. We're finding on our test that the GreenSeal bipolar battery charges faster. So for example, in a golf cart, a traditional lead acid battery might take 17 or 18 hours to fully recharge. Our batteries are doing that in 6 or 7 hours. That has tremendous impact on utilization of batteries, how many turns you have, how you can use it in a plant or a warehouse, let's say, for forklift trucks, etc.
Bringing GreenSeal battery technology to market is highly capital efficient. We don't have to build battery manufacturing plants. We can utilize 80% of the existing sunk infrastructure in an existing battery plant of our licensee, and they get greater margin opportunity because it's actually cheaper to build a GreenSeal battery than any competing technology.
Where we can go from here with this GreenSeal bipolar battery technology is it's a platform technology. We're using it today to make lead acid batteries better, and we're getting great results. But we're not done. We can use this technology with other advanced battery chemistries to make them even better too, and that's what we're working on next.